Why they not let us rename?
Some people don't like.
Hey guys. Does anyone have any questions about the homework? No questions? Okay, cool. See, everyone has their cameras off this time.
Mute.
So if you just came in, do you have any questions about homework? If there's any problem that you would like me to explain, I can do that.
Can you at least give me some juicy and a drink on me?
All right, people are coming in. So do you guys have any questions about the homework? All right, so I'll just wait a little longer. We should have like 30 people, I'd say.
Being 3, 4, and 5. Now we have the
All right, so I'm going to share my screen now. All right, so this is week 6 of Prealgebra. And maybe I'll wait a bit longer for people to come in, and then we'll get started. Alrighty, so this week, what we're going to talk about are ratios, okay? So, What are the topics we're going to talk about? We're going to first talk about what ratios are. I think a lot of you already know what ratios are. And then we're going to talk about proportions. Ooh, why are they disappearing? It's weird. So then we're going to talk about proportions.
People are
And then
drawing over it.
we're going to talk about conversions, okay? So if you don't know what proportions and conversions are, all of those have at least something to do with ratios. All right, so let me get started now. So ratios, what are ratios? Ratios basically compare the quantities of two different groups. Well, what does that mean? Well, for example, if in a classroom there were 10 girls and 7 boys, the ratio of girls to boys would be 10 to 7. All right, and then we use this little funny mark here called a colon. Okay, so we use a colon when we're talking about ratios. And basically, this is how we write it. For every 10 girls in this class, there are going to be 7 boys. So the ratio of girls to boys is going to be 10 to 7. If I wanted to say ratio of boys to girls, that would be the opposite way around. 7 to 10. Okay, so those are basically what ratios are. They compare the quantities of two different groups. So another example I could give is, what if we had 10 girls in a class? Oh, that's not how you write girls. And then we have 12 boys. What's the ratio of girls to boys now? Well, 10 to 12. And just like fractions, we can simplify ratios. So as you can see here, both of these, we can divide them by 2. And the key here is that if we divide or multiply each side of a ratio by the same number, then the ratio stays constant. All right, and then I have 5 to 6. So this means that in this class, for every 5 girls, there are going to be 6 boys in the class. So for every 5 girls, there are 6 boys. But the ratio doesn't tell us exactly how many girls or boys we have. For example, if I had maybe 3 to 7 as my ratio of girls to boys, well, I could have 3 girls and 7 boys, or there could be 6 girls and 14 boys, right? Because this would be the same ratio. Or I could have 9 to 21. So ratios don't tell us exactly how many quantities is in each group, but it compares these two groups and tells us how much they have relative to one another. And also, ratios don't need to be between 2 items. They can be between 3 or more. So I could say the ratio of, in a pet store, dogs to cats to fish. The ratio could be 4 to 3 to 2, right? So the ratio of dogs to cats to fish, in this case, we would just write 4 to 3 to 2, okay? So this means that for every 4 dogs, there are going to be 3 cats and 2 fish as well, okay? So how do we simplify ratios? If I had something like 200 to 300, how do I simplify that? Well, since ratios are so similar to fractions, people sometimes write them as fractions. So this is another way we can write ratios as actual fractions, okay? But in the problem, this is not going to call this a fraction. The problem is going to call this a ratio of ... right? So we just use the dash to replace the colon in this case, okay? So if we have a ratio here, we can simplify just exactly with the rules of simplifying fractions. We'll write this as a fraction and we'll cancel it. Or then now we can turn this back into our regular colon form, 2 to 3. So that's how you would simplify ratios. Ratios are basically fractions, but they're comparing two groups together. Okay, so those are what ratios are. Here are some problems. And guys, please calm down in the chat, because otherwise I'm going to turn it off for everyone. Yeah. So here are the problems. If you finish all of them early, maybe you can try the last one as well, which is a challenge. Uh-oh. So if you get the answer, you can private that to me, and I'll tell you if you're right or not. Don't answer to your because I'm getting a lot of answers right now, so if I don't reply to yours, don't panic or anything, because I really have a lot of them. A lot of people have been getting the second problem wrong, so be really careful when you're doing that one.
What? What? What do you mean?
What do you mean, kid?
What?
So when you chat your answer to me, please write down which problem you're referring to in your answer. So if you answered number 1, then write like a 1 before your answer. I'm gonna go for maybe 1 or 2 more minutes here. Okay, so I'm gonna talk through these now. I think someone's giving me. All right, so I'm gonna talk through these now. So now, how to simplify these ratios? Well, ratios, we can write them in fraction form. So we can write 2 over 2 to 10 as 2 over 10, which is something like this. And if we simplify this just like a regular fraction, this is 1/5 or 1:5. So that's the first one. Now for the second one, it's basically the same thing. 9 over 6, 3 over 2, or 3:2. Okay, so in ratios, the order really matters, okay? So for example, if we're talking about dogs and cats, you cannot switch them around. So now for the last one. This last one is a little tricky. 1/2 to 1/3. How do I do this one? Well, let's first turn this into fractional form. So that's 1/2 divided by 1/3. 1/2 over 1/3. Now what do? I have like a really weird fraction here. Fractions within fractions. What do? Well, if we remember that fractions are basically division problems. So 1/2 over 1/3 is the same thing as 1/2 divided by 1/3. And what does dividing by fractions mean? Well, we can multiply by the reciprocal. So this is 1/2 times the reciprocal of 1/3, which is 3. This is just 3/2 or 3:2. Okay? So the trick here was to turn all of these into fractional form and then simplify them as you would if it was a regular fraction. Now for the next one. This one, a lot of people got it wrong. So the ratio of dogs to cats in the pet shop is 4:3. What fraction of the total pets are dogs? A lot of people look at this and go, hey, we put the number of dogs on the top and they put the other number on the bottom. But if we look at this number is greater than 1. If this number is greater than 1, that means more than 100% of the pets are dogs. Well, obviously this can't be right, because if the answer was 1, then that would mean all the pets were dogs. Even more than that, I can't really visualize that. So if we look at the answer here, we know that it doesn't make sense. So how do we do this? The ratio of dogs to cats in a pet shop is 4:3. So that means for every 4 dogs we have,
I'm listening.
like let's say we have 4 dogs, then we have 3 cats as well. C. All right, let's just have this sample here, right? This sample follows the ratio. We have 4 dogs and 3 cats. This follows the ratio. Well, how many dogs do we have? We have 4 dogs. But how many total pets do we have? We have 1, 2, 3, 4, 5, 6, 7. That is the fraction that is dogs. Okay, so it's the number of dogs over the total. So for these types of problems, these problems want to trick you. So you got to be careful in these. Okay. Does everyone get how this works? So this is 4/7, not 4/3. And the next one is actually pretty similar as well. In the bowling tournament, the top 3 plates. Oops, that was a typo. The plates don't play bowling, but whatever. The top 3 plates get prizes in the ratio 5:2 to 1. If the total amount of money is $1,000, how much does the first place winner get? Well, the first place winner is obviously going to get the largest portion, right? He's going to get the 5. So, what fraction of the total amount of money is this first place winner getting? Well, we have 5 for him, and then we have 5 plus 2 plus 1 as the total, 5/8. So this is the fraction of the total prize that the first place winner is getting. So now if we multiply this by how much the prize is worth, then we'll have the amount of money this guy will get. So this is basically 1,000/8 times 5. So let me do that here. 1,000 divided by 8. That is 122, 45, 125. And then 125 times 5. To $625.
Wait, I need to be
Okay. So I know a lot of people looked at this and went 5/2 to 1. Well, it looks like it's going to be 500, right? But if this guy's 500, then the other guy's 200, and the last guy's 100. And these add up to $800, not $1,000. So you got to be pretty careful with these. Okay? So now for the challenge problem. I have blots, bleats, and blitz in a bag. The ratio of the number of blots to the number of bleats is 3:4. The ratio of the number of bleats to the number of blitz is 5:6. What is the ratio of the number of blots to the number of blitz? Well, I don't like this. I don't like the words they're using, right? So what if I replace all of them with letters? Blots turns into A. So let me replace all the blots with A. Oh, here's another one. And now bleats turns into B. So I'm just labeling these differently because the problem wants to confuse me. It's giving me all these similar words to try to confuse me. So I'm gonna switch these up here. Oh, another one. So I have A, B, and C. The ratio of number of A to B is 3:4. The ratio of B to C is 5:6. What's the ratio of A to C? So this is what we want to find. So how do we do this? How can we combine these 2 ratios and make them into 1? Well, as we saw here in the first one, in the past problem, we had 3 values being connected within 1 ratio. If we'll be able to connect A, B, and C with the same ratio, then we can compare them however which way we want. So how do I get all of them to be in the same ratio? Well, as of right now, both of these have a b in them, right? But their numbers are different. In this one, the b is 4. In this one, the b is 5. If I get each of these b's to be the same number, then I can just combine these ratios together. If I get these to be the same number, then it basically acts as a bridge to connect A and C together. So how do I get these b values to be the same? Well, how do I turn 4 to 5? Well, I can do that by multiplying 5/4, right? And if I did that on one side of the ratio, I have to do that to the other side. So now the ratio of A to B is 15/4 to 5. That's A to B. And then B to C would be 5 to 6. So A to B to C is 15/4 to 5 to 6. So now we just need to relate this A value and the C value. So A to C is just 15/4 over 6, which is 15/4 times 1/6. So that's going to be, what is it, 5/12, or 5:12. All right, so this is a pretty advanced problem. So if you didn't really get that, that's fine. Okay. So now we're going to talk about proportions. What are proportions? Well, proportions are just a really specific type of ratio. So let me give you an example of this. A proportion could be a recipe calls for 1 cup of milk and 3 eggs. This is a proportion. For every 1 cup of milk I put in this cake, I'm going to have to put 3 eggs as well. Okay, so if I make, I don't know, three times as much cake, then I'll have 3 cups of milk and 9 eggs, right? So these are basically proportions. And a common type of proportion problem will be something like this. A recipe wants 2 1/2 cups of flour with 4 eggs. But I only have 3 eggs. So how much flour do I use? So this is a common type of problem. So how do we solve this? Well, how I would solve this is by making a table here. I have a table, flour and eggs. We have one ratio here, which is 2 1/2 to 4. I'm going to write 2 1/2 as 5 halves. 5 halves to 4. Okay, so this is a ratio. And then my next row, I have 3 eggs. Okay, so how do I figure out how much flour I need? Well, let's look. How do I get from 4 to 5 halves? Well, 4 times some number x is going to get me to 5 halves. If I divide each side by 4, I'm going to have x equal to 5/8. So I multiply 4 by 5/8 to get to 5 halves. And if I do the same thing to 3, then that's going to get me to the amount of flour I need for 3 eggs times 5/8. So 3 times 5/8, that's 15/8. So that would be the amount of flour I need. Okay, so making these tables makes it easier to convert through ratios. And since these ratios have to be the same, then the number I have to multiply 4 by to get to 5 halves will always be the same number that I need to multiply 3 by to get to 15/8, how much flour I need. Okay? So that's how you do proportions. Are there any questions? Alrighty, let's do some problems with these. So let me cross out this last one because we're running a little low on time. So the trick here, make a table. Tables help a lot. So when you get the answer, please private that to me. I'll give you guys 1 more minute. Okay, so I think, do you guys want a little more time? Okay, maybe I'll go for another minute. So if you're having a little trouble, make a table. Make things a little clearer in here. Oh. Well, if you guys are still doing the last one, I'm not going to check that one. So I think most of you are getting those right, though. Okay, so I'm going to explain these now. So for the first problem, Sadie is 3 feet tall, and at some kind of time, she has an 8 feet shadow. And Nick is 5 feet tall. How long is his shadow? So I'm going to make a table here. I'm going to do real life, how tall they actually are, to shadow. So the first ratio we have is the girl is 3 feet tall, and her shadow is 8 feet. Okay? So now Nick is real 5 feet tall. So how long is his shadow? Well, how do we get from 3 to 8? That will be the same thing we need to multiply 5 by to get to whatever Nick's shadow is going to be. So how do we get from 3 to 8? Well, 3 times whatever x is going to be 8. If we divide through by 3, we'll have x by itself, x 8/3. So if we multiply 8/3 through the table, we're going to have our answer. So if we multiply 5 by 8/3, we're going to have 40/3. And that is enough. 40/3 feet. Okay? So now for the next one, really similar. So on a map, every 1/4 inch on the map equals 5 miles in real life. Chicago and Minneapolis are 13 inches apart on the map. How far are they apart in real life? Well, let's make a table again. Map and real life. So on the map, 1/4 inch is 5 miles. So now we're given 13 inches. How far are they apart in real life? Well, what do we need to multiply 1/4 by to get to 5? 1/4 times x equals 5. If we multiply both sides by 4, we'll have x equal to 20 times 20. So if we times 20 by 13, we'll get what we need. So 20 times 13, 0, 6, 2, 260 miles. All right. So the trick here was to make the tables, and the tables are going to make things a lot easier to do. Now we have conversions. So in real life, we have a lot of conversions we need to do. So what do I mean? Well, a common one is that, well, how many inches are in 8 feet? How many inches are in 8 feet? Well, you might say, hey, 12 feet and 12 inches in a foot. Well, that's just 8 times 12, 96, right? But why does this work? Is there a mathematical equation that tells us that this is? Well, there actually is, okay? So when we do this, we're going to want to use what's called a conversion factor. And a conversion factor in this case is 12 inches to 1 foot. This is the conversion factor. This is a fact. This is real, right? For every 12 inches, we have 1 foot. So now if we start off with our 8 feet, we can multiply this by the ratio here, 12 inches to 1 foot. Remember how ratios are fractions? All right, and we really need to, it's important to write words in this case, okay? And as you can see here, the words feet, these are going to cancel out, feet divided by feet. I know it's kind of hard to visualize here, but if we multiply 8 feet by the conversion factor here, we can see how the words feet cancel out. English divided by English equals 1, right? It doesn't matter if they're numbers or not. Something divided by itself is always going to equal 1, so these feet are going to cancel out. What's the unit we have left? Inches. So that's what our answer is going to be in. Now we just need to do the math here. 8 times 12, 96 inches. That's how we use a conversion factor. So if you're still a little confused, let me show you another example here. Let's say how many inches in 3 yards. So how many inches are in 3 yards? Here, come on. So how many inches are in 3 yards? Well, we can use 2 conversion factors in this case. 12 inches to 1 foot, that's 1. And then we can have 3 feet, 1 yard. So how do we take inches, how do we take yards into inches? Well, let's start out with 3 yards. How do we cancel the word yard out of this? We can multiply this by the conversion factor, 3. 3 feet over 1 yard. See how the words yard are going to cancel out? These words are canceling out. Now we need to cancel out the feet and turn this into an inch. If we multiply this by our other conversion factor, it is 12 inches over 1 foot. Do you see how the words feet are going to cancel out here? And the only word left here is inches. So that's what our answer is going to be in. Our answer is going to be in inches. So now we have our answer. 3 times 3 times 12 inches. What's that going to be? That's 9 times 12, 108 inches. Okay, does everyone get how we use conversion factors to convert between units? So you may be asking, wow, this is really complex. This is something like this, just a lot of things going on. Why do I need to do this? Well, I learned it this year that in freshman chemistry, this year I did chemistry, and they forced us to use this method because in chemistry you have to do a bunch of conversions. You have to do 5 or 6 for every problem. So this makes things a lot simpler. You don't have to toggle a bunch of equations at the same time. Okay, so that's why it's really important to learn how to use conversion rates in this way. So again, are there any questions about how to do this? Because I really need you guys to understand how this works. Okay, cool. Let's do these problems here then. So let's skip the first one. And skip the second one too. So you don't need to do those 2. Just do second, number 2, and number 4. Okay?
Glitcher.
So I see some people are making some really easy mistakes that come up if you don't use the conversion rates. Because for the second problem, you have a ton of conversions you have to do. So you have it's almost like really important for you guys to use conversion rates on the second one. Because there are a lot of easy mistakes that people make if they just go at it with their brain. I think people are finishing up now. Do you guys need a little more time?
Yeah.
Okay, I'll go for, I don't know, 1 or 2 more minutes. All right, Andrew. Okay, I'm going to explain these now. So the first one, there are a ton of conversions we need to do for this one. So let's first unpack these words and make them into more easier, let's turn them into ratios. So first of all, the first one, 1 tablespoon, I'm going to write it like this, to 1/2 ounce. Now for the second one, 1 cup is proportional to 8 ounce. 1 gallon proportional to 16 cups. Alrighty, so now this problem wants us to turn gallons into tablespoons, right? How many tablespoons are there in a gallon? So we're going to start out with 1 gallon. What conversion rate out of these 3 do we use to turn gallons into something different? Well, we can use this one, 1 gallon per 16 cups. But our main goal here is to get rid of the gallons here. We want to get rid of that word. So if we multiply this by 1 gallon per 16 cups, it's not going to cancel. The gallon is multiplying by the gallon. It's just going to make things more confusing. So we need to make sure that we multiply it in the right direction. So 16 cups per 1 gallon. As you can see here, the words gallon they're gonna cancel out. So now I just have cups. Now I can use this one to turn cups into ounces. I'm going to put cups on the denominator again, so I can get rid of them. 8 ounces. As you can see here, the words cup are going to cancel out. Now I'm going to turn ounces into tablespoons finally. And this part is where a lot of people messed up. This 1/2, it drove them off course. They thought, oh, I'll just do 8 times 16 times 1/2. But no. So as we can see here, we want to get rid of the ounces, right? So that's going to have 1/2 ounces in the denominator and 1 tablespoon in the numerator. And as you can see, the words ounces are going to cancel out. All we have left is the word tablespoon. So all we need to do now is do all the math that's involved. So we have a 1 times 16 times 8 times 1 over 1 times 1 times 1/2. Let's get rid of those ones because we don't need them. So what we have here is 16 times 8 divided by 1/2. What does dividing by a fraction mean? Multiplying by the reciprocal. 16 times 8 times the reciprocal of 1/2, which is 2. 16 times 8 times 2, that's, well, 8 times 2 is 16, so 16 times 16. Let's just do that here. 256 tablespoons. All right. So in the case that you need to do a bunch of conversions here, like in this problem, it's really important to use conversion factors. Now for the next one, we can see that conversion factors will work for not just standard units like cups and gallons and miles and all that. It can work with other things. So we're given a ratio here, 40 words per 1 minute, right? And we're given a 2,000 word essay. So let me write the word word in here. So now we want to cancel the word word. We're canceling the word. So how do we cancel that? We put 40 words in the denominator. Right, 1 minute per 40 words. The word is going to cancel. So we have 2,000 over 40 minutes. So that's going to be 200 over 4. 50 minutes. All right, so we can make conversion factors even with things that aren't as standard. They're not cups or gallons. We can use words per minute, and we can turn that into a conversion factor as well. So are there any questions? Okay, so now it's quizzes time. So I'm going to stop sharing here, share my screen for the quizzes. So here is the quizzes. I'm going to start a game here.
Link, please.
So I'm going to put the link in there as well. So let me copy the link. So I'm going to put the link in the chat as well. So you can, if you click on the direct link, I think it will also get you, wait, where's the chat? So I can't see the chat right now. That's a little weird. So the code is 101351. So you can go to joinmyquiz.com and get in. Or you can go, so I'm going to try to get the link again. The chat is not coming up. So Zoom is not working again. Oh no. Does anyone need the link? Or are you guys okay with going to joinmyquiz.com and putting in the code? So it seems like we're okay. Oh look, there's Pi. He's right there.
Yeah.
Look, there's the game code.
What one?
Okay, so for this quizzes, please don't use a calculator because I want it to be fair. So don't use a calculator. If you do, I'll be able to see. I'll be able to find out. So to keep it fair, please don't use a calculator for this one. For anyone, for that matter, because it keeps the game really fair. All right, I'm gonna wait 1 more minute for you guys to come in. All right, 10 seconds left. I'm going to start. Okay, so remember, don't use a calculator. Have fun. Here it goes. Strategy for quizzes is to take your time. Try to get them right better than getting them fast. Pi is in the front right now. I think that's right. Pi is 5 correct answers without any incorrect. Top 3 right now are Ryan, Pi, and Richard. 4th place is Lily. 5th place, Game Code. Pi is back on top. Pi has 8 correct answers with a flawless streak. 9 now. Seems like Pi is gonna win. Right now, top 5 are Ryan, Pi, Hacker08, number 4 is Richard, and number 5 is Gavin. Pi is number 1 now. 10 correct answers. So right now the leaderboard is number 1, Hacker08, number 2 is Pi, number 3 is Ryan, number 4 is Gavin, and number 5 is Richard. Alright, it seems like top 5 has finished now. I'll give you guys 1 more minute to finish up the game. This week it seems like our top 5 are going to be number 1, Hacker08, number 2, Pi, number 3, Ryan, number 4, Gavin, and number 5, Richard. Alright. So I'm going to end the game right now, right here. Let's see the top 3. 3, Ryan, number 2, Pi, number 1, Hacker08. Alright. Nice job, guys. I hope you enjoyed. I'll see you next time. Bye. See you later.
Bye.
Bye.